Hey guys, so yesterday we talked about how to find mean, median, and mode, which are all measures of averages, and they all give you a really useful number that can represent a data set. But sometimes you want more information than that. You don't just want to know one number that's an average. You want to see what we call the spread of data. Another name for this is the distribution of the data. I realized at this point that I never defined for you what spread and distribution mean. Just really shortly, it means where all the data points are. So if a lot of people answer really low numbers and then a couple of people answer really high numbers when you ask a quantitative question, your data is skewed towards the high numbers. Those high numbers will pull up your average. If a lot of people answer numbers like that are in the middle of your range, and then a couple people answer low numbers and a couple people answer high numbers, that data has central tendency, so that a lot of things are grouped in the middle. That's all spread and distribution are, just like where the answers are, and that's something that histograms will tell you and averages will not tell you. The tool we're learning about today is called a histogram. Now, histograms are a way to represent data graphically, a way to actually make a picture to represent data. We've been graphing on the coordinate plane, but this is a little bit different. We graph histograms on the real number line. What histograms do is they group data into bins. These bins are ranges of numbers. I'm going to lead you through creating a histogram for the set of data that I have on the board, and I think this is the easiest way for you to see how we do it as we go through this example. These are scores from our last quiz. I've actually pulled 20 people's scores. These are real scores. And what we're going to do is we're going to create an image that represents how this data is spread out. When you are first creating your histogram, it's important to identify the range. That means the highest to lowest value that you have. Obviously, looking at this data set, we have a 100 here, so that's going to be our highest. And then the lowest value, I think, is a 31. So what you're going to do is you're going to choose a range that really lets you put all of your data points on this number line, and also will allow you to have evenly spaced bins. I'm going to choose bins of 10 each. So my first bin will be from 30 to 40. The one after that from 40 to 50, 50 to 60, 60 to 70, so on and so forth. What I've done here is I've partitioned my number line into all these evenly spaced bins, and now what I can do is just count up how many data points should go in each bin. For my histogram, I'm going to choose to make each of these bins non-inclusive on the upper end of the range, which means that this one will go up to 40. So if there was a score that was exactly 40, I'd put it in the next bin. Let's see how many should go in this first bin. Now, looking through all the scores, it seems like there's only one score in the 30 to 40 bin. So what I'm going to do is I'm going to make myself a bar 1 unit high. Now, this is going to be on my 1 unit bar. So what I'll do is I'll just make myself a little y-axis, or vertical axis, and I'll mark that as 1. Obviously, I want my points here to be evenly spaced as well, so let me mark the other ones. Okay, so what I've done is I've given myself a y-axis so I can show how many scores go in each of these bins. All right, let's consider the next bin, 40 to 50. Are there any scores that lie in this bin? I don't see any. 50 to 60, I see a 52, so that's just 1. That will go in here as well. And actually, something that's really helpful, and I should have done this from the beginning, is as you mark down your data points, cross them out so you don't go back and think that you forgot one. So we did 31 and we did 52. Okay, let's look at the next bin, 60 to 70. Anything in that bin? I don't see anything. Okay, the next bin, 70 to 80. Well, I've got 77 and I've got 71. So 2 data points go in that bin. I'm trying to make sure that it really lines up here, but yep, that's about right. Okay. And let me cross those out as well. So we did 71 and we did 77. Great. Okay, next bin, 80 to 90. Now this one's gonna be pretty full. I've got let's see, I've got 81, 81, 81, 84, 83, 88, and 86. So that is 1, 2, 3, 4, 5, 6, 7 I should have in that bin. So all my 80s get crossed out, and I put 7 in that bin. Finally, I've got my 90 to 100 bin, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. That should go in that bin. Okay, I'm gonna need another mark on my y-axis all the way up to 9. You guys really outdid yourself on this last quiz, so you're really pushing my histogram. So that's gonna go all the way up to 9. Okay, I can now see the shape of my data based off of this histogram. And in fact, this histogram shows us that this data set is what we would call skewed left. Now that may be a little counterintuitive because it looks like most of my scores are on the right-hand side. But when I say skewed left, I mean I have some outliers on my left-hand side that would pull my average down if I were to calculate a mean score. If I were to actually add up all these scores and divide by the number of scores that I've represented here, I would actually get a number that's a little lower than what the average really is. So this is what we call data that is skewed left. Histograms are really good at representing the shape of data. They really show you the skew of the data, they show you the center of the data. And so they're going to be really good for us when we are considering what kind of measure of average to use. Personally, if I were going to use one of our mean, median, or mode, I would choose median for this one, just because there's a huge chunk of the data is over here. And if I were to use the mean, it would be skewed. And if I were to use the mode, it would kind of be useless because, well, really there isn't one that appears very many times, right? 81 appears a lot, but honestly, I don't even think 81 is a very good representation. I'd feel like somewhere right between the 80 to 90 bin and the 90 to 100 bin would be better, maybe 90, right? So using median would be best here. One last thing, when you're looking at a histogram and you don't have the data set, so say for instance we had this and none of these data points up here, it gives us a really good idea of the shape of the data, but what it doesn't tell us is exactly what the scores were, right? If this were entitled scores on a test, you would know, okay, 9 people got somewhere between 90 and 100, 8 people got somewhere between, or 7 people got somewhere between 80 and 90, but you wouldn't know the exact scores. So it's limited in the amount of information it can give you. It can only tell you where scores lie. It doesn't tell you exactly what the scores are. Okay, that's it for histograms. They're pretty straightforward. Just to recap, here's the steps. Find the range of your data. Find the highest value, find the lowest value. That's going to be the range, or about the range that you put on your number line. Choose bin sizes. You want your bins to be even. I made bins of 10 for mine, but say your range was really small, maybe you'd want bins of 1 or 2, just so that you're not creating one big giant bin and putting all of your data in it, because that wouldn't really help you out to see the spread at all. After that, you just count how many of your data points go in each bin, and you create a bar that represents that number of data points. Having a y-axis is going to be helpful at this point. And that's it. Then you can see the spread of your data. And then you get this beautiful picture that's useful for everyone.